When we rewrite things in an exponential expression, there's two parts to that exponential expression. There is our base, what we're multiplying by, and then there's the exponent, okay, or the power, and this is the number of times we use that multiplier. And again, we want to make sure that we are clear that exponents and multiplication are not the same thing. They're actually, the math is very different for the two. So we don't ever want to say that multiplication and exponents are the same. Exponents are repeated multiplication, just like addition is, or multiplication is repeated addition. We don't say that addition and multiplication are the same. We don't say that multiplication and exponents are the same. They behave differently. So to get familiar with these exponential expressions, we need to make sure we understand how they work. Now we can rewrite exponents with repeated multiplication, and then we can do all our multiplication math on this. So we have a to the power 4. Well, a to the power 4 means that we have a as a multiplier 4 times, and we can rewrite it as multiplication. And that's one way around some problems with exponents, that we can just convert it back to multiplication and deal with it for what we know is multiplication. Here the base was a, and our exponent is 4. So there's our base. Our exponent was 4. Here the base is going to be that whole 2x. Our exponent is going to be the 3. So my base, when I write it out, is 2x. My exponent is 3, and this is going to be 2x. And I have to use both the 2 and the x. 2x, 2x, 2x. Now this is important here that we understand that based on bed mass, we would do the exponents first and multiplication last. Here it's in brackets, so we do the multiplication, so we keep the 2x together. Here the 5 and the x are not connected. Okay, they're not connected by multiplication because this is an exponent, and exponents and multiplication are different. So they are separate terms. So it's really important to recognize that the base of this expression is only the x. Here it's in brackets, so the 2x. In this case here, the exponent is only on the x, so our base is just x. Let me just write this down. So not 5x, but just x. Our exponent is 2, so to rewrite this, we write the multiplication, and then we expand the exponent part. We do not do 5x times 5x. The 5 is a multiply. This exponent represents something different. When we look at exponents, they're for squares and cubes. We have a geometric way we can see it. We can actually draw it. So the geometric representation of squares is a square. So when we square something, we get a square shape, which makes sense. So when I square something, I'm going from side length to a square area. So if I have a side length of 3, I just need to know one side. I can square one side to get the square area. I could rewrite this as multiplication, as 3 times 3. That would give me, any rectangle. When we multiply, we're getting rectangles, but this is a rectangle that is square shape. So we can just skip that kind of formal step. We can just say we're going to square this. We're going to just take the side length and square to get area. Square rooting is the opposite. So we're going from area to side length, we square root. But the model we use is squares. For cubes, the model we use is volume. When I cube something, I get a cube. Okay, it makes sense. So when I cube a side length, I'm going to get the amount of volume inside. How many cubes fit inside here? So if I have 3 meters, if I cube 3 meters, I can draw in 27 cubes into this space. Okay, it's kind of hard to see, but you can count 27 cubes in there if you were actually to draw each individual cube in. When we get to fourth powers, powers of 4, since we only live in a 3D world, it is very difficult to conceptualize and show and draw a power 4. However, there are ways it can do it, but these are much more advanced. But for cubes and squares, we can represent squares with square area. We can represent cubes with a cube volume.